Okay, thank you very much. Devesh Gupta from PCCW Global, based out of Hong Kong. And I'm responsible for the professional services under the umbrella products that we have on our platform under Console Connect. So today's presentation is about AI agents and how to open NAS networking to enterprises beyond portals. Just to give you a brief automation journey overview of our company, back in 2018, we kind of acquired Console Connect and started our automation for all of our connectivity services. We kind of automated our BSS and OSS processes and all the different layer 1, layer 2, layer 3 networking products like all of the forms of connectivity. And while doing that, during the same years, we kind of used a microservices and API-first approach. So all of these functionality that we put on our platform, it was available via a portal, and also APIs were available. So for customers who had their own portals and they wanted to integrate in the backend with us, same functions were available through APIs. In 2024, we came up with an LSO adapter that we've put up in open source. That's mainly because all this development that we have done, they were built on proprietary APIs. And many of the customers were looking for a standard-based API. So the approach we took was to put an adapter in between, and it converts the native, our legacy APIs onto a Mplify compliant API. 2025, we actually went and got the adapter and our Console Connect API certified under the Haley release. And so those are available to customers today. And 2026, we are actually working on implementing MCP and opening these APIs onto LSO and then also to Agentic AI with the agents. So why do we want to go there and why do we need this? So from enterprise customers' perspective, you can see the trend has been very clear. From search, where you kind of have a list of websites, and then you search for the required information. It has moved on to when the OpenAI ChatGPT was launched in November of 2022. We moved to an answer type of response where the LLM knows what you're asking for, and then you get the response right there in the chat response. And from there, we have moved on to AI agents, which can actually perform and act on your behalf. So it's an outcome-based, not even a search. It's basically something that you're commanding and that agent does for you. So this is where the enterprise customers are headed, and that's what they are looking for in the offering that we are providing as service providers. So to answer to that, what we've done is, as you can see that we have automated our network and enabled it through either a web portal or through standardized APIs. Now we have added a layer there which there is an MCP server sitting on top of the standard APIs. And that basically opens up our NAS services to the traditional carriers and NAS providers who are still connecting with us through APIs, but with also AI agents who would now connect using MCP into our backbone. The type of functionality that we are trying to bring out here, on the bottom left corner, you can see sales agents who are basically either pricing assistant or order managers. Now these are, I think from gathering the feedback from our enterprise customers, those are the main, or I would say most requested functions that they have requested, and those are the ones that we are trying to match. So pricing assistant, ordering assistant, ticketing assistant, and service management. Just to give you a bit of an insight in the framework, so you need to kind of put in place an MCP server and open that up to internal APIs to be able to provide access to agents back to the network. And there are two options that we are basically looking to offer. The first one is for enterprise customers who don't have any kind of agent deployment in their network, so they can just simply come and register to our portal as before. And in this case, what they would have is they can invoke pricing agents or ordering agents, which would assist them in dynamic quoting and intent-based ordering. The second option, of course, is for customers who have AI agents implemented, and they would like to in the backend integrate to our MCP servers, then they would need to connect back to and get authenticated, and then we could do it. So there are two options that are available there. I mentioned that already. So these are the type of use cases that are most relevant for enterprises who are buying NAS services from us today. And so today I'm going to show you a demo of Order Manager, and if we have time, then I can show you for a pricing assistant also. So for the pricing assistant, I have a demo where an agent would request for internet on demand pricing, and it is asking not just for a price, it would ask for comparison between burst and a fixed price. So basically there is an intelligent back-end processing that needs to be done to address that. And the second one is an order manager, so that actually is connected back to the LSO API, so it will perform all the functions that we have very well known under the LSO, so address validation, quote, order, and inventory. So let's go with the first one, the order assistant. That's the simple setup that we have. The AI agent talks to the console connects MCP server, which then connects to our APIs. In this flow, we would go one by one. It would show you the address validation for a particular data center port in Singapore, and then we would go on and show you the order and inventory. So Tom, we could play the first video, please. Okay, so this is basically using a cloud agent, and the first thing you would do is list. So you could actually, in fact, put an address also. You could say that please provide connectivity to a particular address. In this case, we are saying, okay, what do you got in Singapore? So we'd list out all of the known data centers on our network in a particular city. So it shows you in the backend, you can see that it would invoke the MEF address validation API, and then provide information based on the schema that's compliant to the Mplify format. And then in the backend, it would go and fetch information and present it in a table. So you can see here, it's already listing all the data centers that we have, what is the readiness for ports, and who's the operator there. Some of those are our own POPs, some are partner POPs where we interconnect. So there are about probably 30 odd data centers that you can see there. Next, what we would do is we'd say, okay, so these are the data centers available. We'll pick one. So you can see there, 33 ready, monthly ports, active in 7 of them, things like that. So I'll say, okay, give me a quote for a 1 gig access port, and then I'll pick one of the data centers from the list and say, okay, for this one. So here it's, let's say, Singapore, and put that in the prompt. Okay, so it goes, this time it knows it has to invoke the quote API. The last time it was a address validation API. Okay, so the quote API now fetches the data center. It also fetches the unique ID for that data center. So this is all when we were training the agent here, it basically needs to know what is it that it has to provide in order to run that API. And so the first time it fails, it can actually query and ask me, hey, I'm missing a parameter, what do I need to do? So that is all pre-training. Once it's done, it's very seamless. So you see here, it's already started quoting. It gives you a USD 450 quote for a port, a 1 gig port in the data center. Next, it prompts you, hey, do you want to place an order for this now? So I'll go ahead and say, yeah, please place an order. And here's my buyer ID, which I need to place the order. So it would, this time, it would invoke the order API in the backend again, provide the legit conversion for all the required information. And in this case, it would invoke the order API and then place an order in the backend. You can see here, there's a product order that has been ordered already, and there is an acknowledgement that comes up. Lastly, what I'm going to do is I'm going to show you that the order has already been implemented, been acknowledged, and it is registered in our portal. So you can see get order product order. It's an inventory API, which would basically show you the status of the order as acknowledged and in progress. And lastly, this is the actual portal where the AI agent was working in the backend. So you can see under the list of all the ports, the last one is the one that we just ordered. So it's actually running on our actual Console Connect portal in the backend. So that's one. If I can jump on to the second one real fast. Can you switch on to the slides again, Tom? Yeah, thank you. So the next one is a pricing assistant. Here what we are doing is, again, the port that we just ordered in the first demo, I'm going to order internet on demand service on that port. And I'm not just getting the price, because this is a demonstration of a pricing assistant. I'm trying to do something more than just getting a price. So here I'm saying, okay, so I have a 1 gig connection. Should I order a fixed bandwidth, or should I order a burstable? Okay, and how it works is, if it's a fixed bandwidth, then you have a rate of about $390 per month. Whereas if, let's say, you order a 1 gig port and you only select for burstable, then you would be charged on usage. So what is the break-even analysis for me for one against the other? So if you go and you run the second file there, Tom, please. Okay, yeah. So in this, what we do is, so this IOD product is basically for regional providers and also resellers like ourselves. And we provide connectivity with either private IP or public. So if a customer has their own ASN, then they can bring in their own IP address. But if they don't have their own ASN, then we provide an IP address, right? So what we do is, based on who's logged in, we can check and pull their information. In this case, the customer who is requesting for an internet port, they already have 2 public ASNs published, so they can choose to use those to order an IP connection. Or they could go and say, "Nay, just all give me a public IP as well, and give me a 1 gig port." So that is what I'm going to prompt here. I'll say, ignore these 2 public ASNs. Just provide me a public IP and a 1 gig port with IOD. So, and then compare the pricing of the burst versus the fixed, and let me know what should I order. Okay, so here the prompt says that I have IOD pricing inquiry, and looking at that 1 gig port in Singapore, I'm wondering the pricing difference between a burst, and at what point I should go for a fixed versus burst, okay? So in this case, the difference is the cloud agent running, it would go and invoke the same API multiple times. In the previous one, we show 4 or 5 different APIs being run by the agent. Here it's the same pricing API for IOD, but we're running it multiple times because the prompt is different. It is saying, hey, compare 2 scenarios. We could apply this to anything. We could say that, hey, I need an end-to-end pricing. So you might have a segment from one partner, another segment from another partner. And so if all the tools are available to the MCP, it can do complex work. That's the basic crux of this demo. So here you see it has run the same pricing API multiple times, and it's showing you the burstable is good for most of the conditions, except if you're consistently using more than 900 meg on that port, then you can just go for a fixed one. But otherwise, the break-even point is 932. So it is actually doing that calculation and showing you. Thanks. So those are the 2 presentations I wanted to show. Any questions? So just a quick takeaway, the reduction, main reason to move here is, first, the enterprise customers, they are requesting for an agentic way to connect to our portals and then get information. The other side is that for integration, it actually reduces a lot of effort. You don't have to go API by API. If you integrate using AI agents, the MCP has a discovery function where you can actually in the backend discover the APIs and see how to use them. Learn that, and then that becomes much easier for carriers to interconnect. Another thing that I could say is that LSO API versioning, a lot of our partners, they are on different versions of LSO APIs. And here, if you're integrating through an agent, I think all that complexity is hidden, because the MCP would discover a newer version and it will know how to work with it automatically. You don't have to do anything. It's basically part of the discovery work. So things like that. I mean, there's a lot of improvement and efficiency gain that you can see as a result of this. Yeah.
Devesh, thank you very much for this presentation. I have one question, especially on the second use case that you have shown,
okay.
Which is the burstable, right? So traditionally, telcos used to offer, especially for the layer 2 connectivity, couple of products. The first one is carrier Ethernet with fixed capacity, the way you have explained, right? Which could be 1 gigabit port. And we also used to have a product which we used to call as IP transit, Yeah. And IP transit used to have exactly just what you explained as a second use case, which is going to have a burstable, which is usage-based consumption pricing. So this second use case, how it is different than this IP transit kind of product?
No, so the internet on demand is that product. It's basically internet access, tier 1 internet access. It runs on our AS3491, like our network. And the definition of our port, when you order a port, the first demo that I showed you, it's just ordering a port on our network. Once you do that, it's a multi-service port. So you could actually carve it out with multiple VLANs. You could have internet traffic running on one. You could have Ethernet running on another one, that kind of a thing. So the port, the total burstable ceiling is the port. So if it's a 1 gig port, you can go maximum up to 1 gig. If it's 100 gig, you can go up to 100 gig, right? So in the burstable one, what happens is we basically do a rate limit, and if there is no burst, so if a customer says, I want on a 1 gig port, I need a 500 meg bandwidth, so we could just rate limit it. That's how it would be done. And if it's a burstable one, we would put no cap there. So they can go all the way to the capacity of the port, and they're charged based on usage. That's what it is. So in the break-even analysis that you were seeing there, what the AI bot mentioned is that, hey, there is a per meg charge. So if your annual monthly usage is below, let's say, 800 meg consistently, then go for burst. If it is consistently higher than 800 meg, then just go for a fixed bandwidth 1 gig port. That's what it is showing. But it's the same product that I was referring to. Thank you very much.